All right, good afternoon. Just looking at what we have with our Chapter 2 test review, and just kind of going back to what we have with quadratic functions. And we have in the first problem from the review set, and we have a function f of x. Again, f of x is a functional notation for what we otherwise say is going to be y. And here we have set equal to negative 2x squared plus 16x minus 36. Okay. And so we have for this first item, okay, so we have f of x. Okay, we have negative 2x squared plus 16x minus 36. And again, this is the standard form of a quadratic function, and I want to convert what I have here in terms of the vertex form. And again, just for the vertex form, okay, we're going to have, in this case, all right, we're going to have that f of x is equal to a times the square of x minus h, followed by the addition of k. And if I convert what I have from the standard form and going into, once again, the vertex form. Okay, so first of all, if I look at separating the variable terms, okay, so you have f of x. Okay, so I have negative 2x squared plus 16x, and we have minus 36. And again, I'm going to set things up where I can complete the square, and I want the first term in the parentheses to be x squared. Okay, so but right now we got negative 2 out at the front. So if I factor negative 2 from the binomial, negative 2 will go into negative 2x squared, x squared times, and negative 2 into positive 16x. Okay, that is going to be minus 8x. Again, we have followed by the subtraction of 36. Again, just double checking, so you have negative 2x squared. You got plus 16x minus 36. And I want to make the expression I have inside the parentheses into a squared trinomial. And again, we have in the process, again, I'm going to have with completing the square. Okay, so again, for completing the square, I'm going to take the coefficient that is next to the first order x displayed. Okay, so I have negative 8, and I'm going to again apply two operations. Okay, one is going to be take half of the coefficient and then square. Okay, so we have half of negative 8 is negative 4, and negative 4 squared, okay, that is going to be positive 16, and that negative 4 is going to reappear in the vertex form. Okay, now, so for what we have in the setup, okay, now we got f of x is equal to negative 2, and we have times the quantity. Okay, so we have x squared minus 8x, and again with the completion of the square, okay, so I'm going to add 16 at the front, and I have to create a bit of a balance here, okay, because right now as I'm adding 16, okay, notice I have negative 2x squared plus 16x. Now negative 2 times 16 again is going to be negative 32, and if I take 36 away, not 32 but 36, okay, I'll have a minus 68. So I want to get it back to having it in balance with minus 36. So what I'm doing in effect is that as I'm adding 16 within the parentheses, it is within the whole framework that at the front, by adding 16 within, I'm actually adding negative 2 times 16, so I'm actually applying negative 32 at the front, and I want to offset this deficit by adding 32 at the back. Okay, and so for what we have in this setup, okay, so we've got with f of x, again we have -2, again, times the quantity of x squared minus 8x plus 16, and we have -36 plus 32, okay, that will be -4, and in the case of the vertex form, so we have f of x, and we have is equal to -2. We have times the quantity. Okay, now with x squared minus 8x plus 16. Okay, this is going to be a squared trinomial. And again, from x squared, I have the square of x. Now for -8x plus 16 in terms of how this is completed out. Again, I got this 16 from having squared out -4. So I'm going to have -2 times the square of x minus 4, and then we have followed by the subtraction of 4. And if you notice, okay, we have this formation is in line with the vertex form. So you have a times the square of x minus h plus k. And so looking at what we have in the development, okay, so we got in this particular layout, okay, so you have -2 at the front, so we have a is equal to -2. And for x minus h, that is represented by x minus 4. So again, if I have x minus 4 equal to 0, and we have my h value to be that resulting x value, in this case, which is going to be at 4. And again, we have the value of k is equal to -4. Okay, and so just some details here. Okay, so you got your vertex. Which is going to have the ordered pair hk, which specifically will be 4 and -4. Okay, and just some details with regard to a. Okay, so a is negative. In other words, since a is less than 0, okay, you're going to have the graph is going to open downward. Okay, and since the graph opens downward, okay, you have graph to be opening downward from the vertex, and the vertex in this case, which you have a 4, -4, okay, that is going to be the maximum. Okay. All right. So for the line of questions we have in number 1, okay, in terms of whether the function has a minimum or maximum value. Okay, this is not a yes or no question. Okay, now this is going to be what is the vertex. Now if the coefficient a is negative, then the graph opens downward, so the vertex is going to be a maximum. But if the graph opens upward, where the vertex is at the bottom, the vertex is going to be a minimum. Okay, so in this case, the function is going to have a maximum. And it's asking where does the minimum or maximum value occur. So you have your x value, okay, and again that's going to be your h value from the vertex. Okay, so I'm just going to add in a little bit of detail here. So you have x is equal to h, and that is equal to 4. And what is the function's minimum or maximum value? That's going to be your corresponding y value, or in this case your k value. So you have like your y is equal to k, and that is going to be at -4. Okay, so in this case you have the maximum value, okay, is going to be at 4, and the function's minimum or maximum value, again, that's going to be the second coordinate, which is going to be at -4. And just to provide a bit of a visual, okay, and if you notice, okay, we have with the graph of this particular function. Okay, so you have f of x is equal to -2x squared plus 16x minus 36. Okay, and so the graph is going to be opening downward, and notice you have the vertex at 4, -4, and so that is going to be the location of the maximum. So it occurs at x equal to 4, and that maximum value, that is your corresponding y or k value, is going to end up at -4. All right. And we have, in the case of the second item, okay, now we have a function g of x is equal to 3x squared plus 30x plus 77. Okay, and we have the same line of questions. And for this function, okay, so the coefficients, again, we have 330 and 77. Again, so like f of x, g of x is just another way of saying what we have for y. So here we have g of x as it is presented. Okay, we have displayed in standard form. And again, I want to rewrite this in terms of the vertex form. So I'm going to separate once again the variable terms apart from the constant. And if you can go ahead and envision going ahead and factoring out 3, you're welcome to do so. Okay, so we got 3x squared plus 30x apart from 77. And again, to be able to set this up where I can complete the square, again, I want the first term inside the parentheses to be x squared. So with the leading coefficient right now at 3, I can go ahead and factor out 3. And we have times the quantity of x squared plus 10x. We have plus 77. So I'm maintaining consistency. 3x squared plus 30x plus 77. Now, in crossing over to completing the square, okay, so again, within the parentheses, the first order x term has a coefficient of 10. So I'm going to take half of this and square. So half of 10 is going to be at 5. Oops. Don't know what happened there. So yeah, 5 squared is equal to 25. And we have in terms of following through. Okay, so we have g of x. And we have 3 times, okay, the quantity. Okay, so we have x squared plus 10x. Okay, and we're going to form the trinomial by adding 25. Okay, and again, I want to keep everything in balance with respect to what we had before. So I had 3x squared plus 30x plus 77. Now by adding 25, I'm creating a bit of an off balance. And I'm adding not just 25, but what is going to be 3 times 25. So by adding 25 within the parentheses, I'm adding 75 overall. So to override the surplus, I'm going to take away 75 at the end. So we have, in following through, so we have g of x, and we have equal to 3 times the quantity of x squared plus 10x plus 25. And we have 77 minus 75. Okay, so that is going to leave us with 2. And for what we have in the case of the vertex form, okay, so we have for g of x, okay, so you got 3. Now for x squared plus 10x plus 25, again we have a square trinomial. And from x squared I have the square of x. And again, to have gotten to this trinomial, I had to add 25, and that came into existence upon squaring out the number 5, in this case a positive 5. So the trinomial is going to be the square of x plus 5. Again, we have plus 2 at the end. Okay. And so we have, with the vertex form, okay, again we have with our coefficients, okay, so we have the leading coefficient a is equal to 3. And once again, a is positive. So in this case, okay, the graph is going to open up. From the vertex. And since it opens up from the vertex, now the vertex is going to be the bottom point in the graph case. So the vertex will be the location of the minimum. All right, now for x plus 5, if I set x plus 5 equal to 0, now our corresponding h value is going to be the 0 from setting x plus 5 equal to 0. So you have h is equal to x is equal to negative 5. And we have with a k value. Okay, now the k value is going to be positive 2. And so for what we're going to have in the case of the vertex, so the vertex HK, that's going to be at negative 5 and 2. Okay, so the minimum, we're going to have a minimum. It's going to occur at x is equal to h is equal to negative 5. And the minimum value is going to be at 2. Okay. So we have just for the numbers here. Okay, so in terms of whether the function, okay, does the function have a minimum or maximum value? And in this case, we have a minimum. And notice you have a shuffling of the order of the questions. And number 1 says, where does the minimum or maximum value occur? You have x equals. And notice that this is the last question. So again, we have with our x value, in this case our h value, again, we had the vertex located at negative 5. And again, the minimum value is going to be at 2. Okay, so you have like x is equal to h is equal to negative 5. And for the minimum value, you have like your y is equal to k is equal to 2. Okay, all right, and just putting on display. Here we go. Okay, so you had the function g of x is equal to 3x squared plus 30x plus 77. And notice we have our vertex. Again, that's going to be the point from which the halves of the parabola are going to open. And so we have at negative 5 and 2. Question? Okay, now we have in the case of the next item. Okay, so we have see, we've already looked at number 3. Okay, so we have yeah, we've already factored W. See, 4 we dealt with the zeros and the multiplicities. 5 we've already encountered. Okay, now for number 6, okay, this is what we have regarding the end behavior of the graph of a function. And for what we have in the case of 6, okay, so we have so we got f of x is equal to the negative of the square of x plus 1. And we have times the quantity of x minus 1. And it says to choose the end behavior of the graph of f. Okay, now for the end behavior, okay, now this is going to be contingent upon the nature of the highest degree term. Okay, so we got this function, and I'm going to do a little bit of color coding here. Okay, so you got a negative sign. Okay, so you can read this as if it is like negative 1 again we have times the quantity of x plus 1 squared. We have times the quantity of x minus 1. Okay, so just looking at the okay, so you got the negative, you have like negative 1, and then looking at formulating what the highest degree term is going to be. So looking at the factors x plus 1 and x minus 1, from x plus 1 the higher order term is x, and that is going to be squared. And then from x minus 1 I have just x. Now the highest order term okay, so we have like negative 1, and you have times x to the second, and you have times x. Okay, so again, just repeating, so you have negative 1. Now the square of x, okay, that's going to be x squared. And we have times x. And once we cluster together, we have a negative times a positive is a negative. And x squared times x becomes negative x cubed. All right, so the highest order term is going to be negative x cubed. And from the negative sign, okay, and again, so you could just write that as negative 1x cubed. All right, so we have for the highest degree term coefficient, you have your a of n is equal to negative 1. And for the degree of the highest order term, okay, that is going to be at 3. So we have from the leading coefficient, okay, that is negative. And with 3, okay, so you have the power of the highest order term, and thus of the whole function, okay, that is going to be odd. So again, we have a of n is negative. And we have that n is odd. Okay, so we have in the case of the end behavior, remember with odd powered functions, okay, it's going to be up at one end, down at the other, and with the coefficient being negative, okay, think like negative, like ending up going down. Okay, so it's starting on a higher note and then it ends up going down, whereas if a of n were positive, think of like positive note, you have left is down, but it ends up to the right going up. So we have in the case of the end behavior, okay, so if it's going to be up to the left, and we say we have rises to the left, and it's going to fall to the right. Okay, and just a little different phrasing in case you have up to the left, down to the right. Okay, so that's going to be the end behavior in this case, right? So we got that for part A. Now for what we have next, okay, it says to list each real zero according to the behavior of the graph at the x-axis near that zero. And we're looking at identifying the zeros and where the graph is going to cross as well as touch the x-axis. So we have, in the case of, going back to our function, okay, so you have the negative of the square of x plus 1 times the quantity of x minus 1. Okay, now in the case of the zeros, notice you have with your factors, you have in the letter x, you have x plus 1 and x minus 1. So we have x plus 1 is equal to 0, so we have x equal to negative 1. And if x minus 1 is equal to 0, okay, so you have that x is equal to 1. And I'm just going to mention something. Okay, so we have just kind of stressing the degrees here. Okay, so x plus 1 is to the second. X minus 1, okay, we have implicitly that this is going to be to the first. Okay, so we have with the zeros. Okay, so we have x equal to negative 1, as well as x is equal to 1. And for the multiplicities, okay, so negative 1 stems from x plus 1, which is raised to the second power. So negative 1 is a multiplicity 2. X equals 1 stems from x minus 1, okay, and that factor is a first order. So 1 has a multiplicity of 1. And in terms of crossing or touching the x-axis, okay, negative 1 has an even valued multiplicity. So that is going to touch at x is equal to negative 1. And since 1 has an odd valued multiplicity with the number 1, okay, it's going to cross the x-axis at x is equal to 1. Okay, so for what we have within the framework here, okay, so we've already got the end behavior, and okay, so for the zeros where the graph crosses the x-axis, again, that was at 1. And where the graph touches but does not cross the x-axis, again, that was at negative 1. Okay, so in this case, we have 1 and negative 1. Okay. Now for the y-intercept, of the graph, okay, so for the y-intercept, okay, you're looking at what y is going to be whenever x is set to 0. So looking at what we have here, so you have y is equal to f of 0. And we have like the negative of 0 plus 1 squared times the quantity of 0 minus 1. And let's move this on down. Okay, so you have like the negative sign is negative 1. 0 plus 1 is 1. That is squared. And we have 0 minus 1 is negative 1. And just bunching together. So you got negative 1. 1 squared is 1. And so we have negative 1 times 1 is negative 1. And then in turn, negative 1 times negative 1 is a positive 1. So we have for the y-intercept, okay, two modes here. You can say that y is equal to 1. Or in this case, you're going to have at the ordered pair 0, 1. Okay, so we have in the formation. Okay, so for the y-intercept with the graph of 1, okay, so you're looking at your y value, and again, that is going to be at 1. And in terms of the graph that we have for this one, now let's go ahead and just put this on full display. Okay, so again we have f of x is equal to the negative of the square of x plus 1 times the quantity of x minus 1. And if you notice, okay, we have the end behavior. For the end behavior, again you have rises to the left or up to the left. And then we have to the right. Okay, so it's going to fall. And we have just in terms of the contact. Okay, so so we had the graph to touch at x equal to negative 1. And once we get to x is equal to 1, okay, so you have at that location, okay, the graph is going to cross the x-axis. Okay, and again you have with your y-intercept, again that location is going to be at 0, 1. So you have in behavior, rises to the left, falls to the right. And again for the zeros and the multiplicities, again the graph ends up touching at x is equal to negative 1 and crossing at x is equal to 1. All right, now for what we have in the case of, again, working with functions. Okay, now we dealt with, we've already got 7, number 8, and we looked at the synthetic division from that particular set, as well as the remainder and the factor theorem portions. Now, where the rational functions are going to come in, and we have for these two items, okay, we have looking at what is going to be the best matching graph, okay, for f of x. And in this one case, so we have so again we have f of x is equal to 3x plus 6. You have all over x squared plus 2x minus 8. And just kind of taking what we have here. I know it's a little bit of an added step, but just in the case of the domain, again, x squared plus 2x minus 8 cannot be 0. And in factoring case, you have the quantity of x plus 4 times that of x plus 2. That x minus 2 cannot be 0. So if x plus 4 cannot be 0, then we have the x cannot be negative 4. And if x minus 2 cannot be 0, okay, well we have the x cannot be positive 2. So you have for the domain, okay, we have those values of x less than negative 4, along with those values of x greater than negative 4 and less than 2, and we have, for the rest, we have those values of x greater than 2. Okay, now, looking at what we have for the function. Okay, so we got 3x plus 6, again, over x squared plus 2x minus 8. And if I factor for what we have in the numerator, okay, so 3 times the quantity of x plus 2. Again, we have in the denominator, I have the quantity of x plus 4 times that of x minus 2. And notice both x plus 4 and x minus 2 remain. Okay, and so for what's going to happen here is that we're going to have vertical asymptotes at x equal to negative 4, and x equal to 2, and just sort of looking at a process of elimination. Okay, so you got two vertical asymptotes. You have x equal to negative 4 and x equal to 2, and just concerning what we have with f of x. Okay, if you notice we don't have x equal to negative 4 or x equal to 2, so A is disqualified. Now we've got x equal to negative 4, x equal to 2, so B is still in the running. And C is going to be likewise. And we've got x equal to negative 4, x equal to 2, so that's still in the running. E is out of the picture since we don't have those vertical asymptotes. And F, okay, we have, this is going to be out of the running. Okay. Okay, so you got the vertical asymptotes. Now, for any other asymptote, again, this comes down to degree comparison. And for what we have in the numerator, again, read this like 3 times x to the first, so we have that n is equal to 1. And we have in the denominator, okay, so we have that m is equal to 2. So we have that n is less than m. So this is going to signal that we're going to have a horizontal asymptote at y is equal to 0. And see if that's going to make a difference in terms of the process of elimination. So it looks like for all of these we still have the, still have the same vertical asymptote. It looks like all of these have the same horizontal asymptote. And we have, in the case of, where we might have, okay, so we've got the same asymptotes throughout. And what you can do is that in terms of, what we can do in terms of if it's going to be any one of these items. Okay, so after the round of asymptotes, you can determine, say, what the y-intercept is going to be. So we can say we have y is equal to f of x, or in this case, which is going to be f of 0. And so we have 3 times 0 plus 6. We have all over 0 squared plus 2 times 0 minus 8. And so we have 6 over negative 8. And so that is going to be negative 3/4. Okay, so the y-intercept we're going to have at 0, negative 3/4. Okay, so you're going to have the location beneath the x-axis. Okay, and so if you notice, okay, we have now we have all the same asymptotes in graphs B, C, and D, but we're looking for where the y-intercept is going to be 0, negative 3/4, and it should be beneath the x-axis. Notice the y-axis. Along the y-axis, we have the y-intercept above the x-axis, so the y value is positive when it needs to be negative. Here we have a positive y value, and here, okay, we have about negative 3/4 for the y-intercept. So graph D is going to check out, and so in terms of which one is going to be best suited to represent the function f of x equals 3x plus 6 over x squared plus 2x minus 8. That's going to end up as graph D. Okay. Now, in the case of h of x, okay, so here we have 8 over x squared minus 2x minus 3. Okay. And we'll hit the reset button here. So you have with h of x, you have 8 over x squared minus 2x minus 3. Okay, and just looking for the domain. Okay, so you have in the factoring. Now this ratio is already, looks like, yeah, we have a constant in the numerator. So that is already in simplest form. Okay, so here we have x cannot be 1 and that x cannot be 3. And for the terms in the domain, so we have those values of x less than negative 1. We have those values x between negative 1 and 3. And then you have followed by those values of x greater than 3. And just for the factored form of this ratio, so neither factor from which the restricted values originate will be eliminated. Okay, so both of these restricted values are going to become vertical asymptotes. Okay, so those are the vertical asymptotes. We have x equal to negative 1 and x is equal to 3. And I'll go ahead and tackle the other asymptote. Okay, so for what we have in the numerator, okay, there's no x term. So we have, again, n is equal to 0. And from the denominator, okay, have the m is equal to 2. And so we have for the setup, okay, so you have the n is less than m. So there's going to be a horizontal asymptote once again, which is going to be at y is equal to 0. Okay, so just looking at what we have in the groups. Okay, so we have, so you got your vertical asymptotes, x equal to -1, x equal to 3. And again, we have the horizontal asymptote, okay, which we have at y is equal to 0. So just looking at what we have here, so got -1, 3. That's still in the running. You know, b is going to be out of the picture. And we don't have the same vertical asymptotes for graph C. Same thing with D. We got -1, 3, 0, -1, 3, 0. Okay, so this time graphs A, E, and F, which were the first to be eliminated in testing for the graph of the function f of x. Okay, okay, these are now the ones in the running in terms of defining h of x. Okay, so we have in the mix, okay, and it's going to follow. So if we look at the process of elimination, okay, so you have intercepts, or in this case the y-intercept, that we can potentially use as the deciding factor. Okay, and in the case of the y-intercept, 0y. Okay, so you want to have that y is equal to h of 0. And so you have 8 over, and then we have what's going to be over -3. And so we have for the y-intercept, okay, so you have 0, -8/3. So that's almost at 0, -3. Okay, so if you notice, just kind of looking at the process, okay, so we have, looks like we have 0, let me zoom in on this. For the y-intercept, okay, so it looks like you have like -1, -2, -3. Looks like that might be the one in the running, whereas for graph E, for the y-intercept, that's in the positive, almost +3. So this is going to go out. And for what we have in the case of F, that y-intercept, okay, that is above the x-axis, so, and we want the y value in the y-intercept to be negative, and that is the only one here. So for h of x equal to 8 over x squared minus 2x minus 3, out of all the graphs that might possibly represent this function, okay, that is going to be choice A. Okay, so D is in reference to f of x, and A will be in reference to h of x. Now, in the case of what we have with item number 14, so we have in the case of the rational functions, okay, so this time around we have f of x is equal to 2x squared plus 2 all over x squared minus 2x minus 3. Okay, now I'm going to sort of bypass the domain part, but if I go ahead and write in factored form, So you got 2x squared plus 2. Now for factoring, okay, we have 2 times, okay, the quantity of x squared plus 1. Now for x squared minus 2x minus 3, it's like we'll have x plus 1 and x minus 3. Now I'll just mention, okay, so we got, again, the denominator cannot be 0. I'll just mention for the domain. So again, your x values of -1 and 3 are going to be restricted. And since these factors, x plus 1 and x minus 3, are not going to cancel, that means that we're going to have the vertical asymptotes at x equal to -1 and x equal to 3. And if we look to see what other asymptote there might be in existence, so we have in the numerator, okay, so have n is equal to 2. In the denominator, okay, we have the m is equal to 2. And we have, for the degree comparisons, okay, so we have the n is equal to m. And from this, okay, so you're going to have a horizontal asymptote, and it's going to be non-negligible. So you're going to have that y is going to be equal to the constant resulting from taking the ratio of the highest order terms in the numerator and denominator. So you have 2x squared over x squared, and so that will go to y is equal to 2. So you got -1 and 3, to which x is set equal for the vertical asymptotes, and we have that y is equal to 2. And just looking at what we have in the process, okay, so you have, we have for the graphs, okay, so you have -1, 3, y is equal to 2. So A is in the running. You got -2, 3. Okay, so you don't have quite the same thing with B. So B is going to go out. Since it does not have x equal to -1 as an asymptote, we got -1, 3, but we have the wrong horizontal asymptote for graph C. Got -1, nope, graph D is out of the picture. For graph E, okay, so we have the wrong horizontal asymptote. And we have, in the case of, what it boils down to, say x equal to -1, x equal to 3, y is equal to 2. So it's going to come down to either graph A or graph F. And if you notice in graph A, we have a positive y-intercept. Graph F is going to be a negative. And so the tiebreaker essentially is going to come down to the location of the y-intercept. So in this one, we have y is equal to f of 0. It looks like we just about stop right there because it looks like we're going to have the outcome to be negative. In fact, we got 2 over -3, so we have y is equal to -2/3. And it turns out that, okay, for the y-intercept, okay, it's going to be in the negative zone. And here we have a positive y value, so A goes out. And so it looks like the best fit is going to be graph F. So for 2x squared, plus 2 over x squared minus 2x minus 3. Okay, looks like we're going to have graph f, okay, for this first function. Okay, now for g of x, okay, so you have 2x minus 2 all over x squared minus x minus 6. Okay, so for that particular part, I'm just going to go ahead and write the domain. Again, so that would be whereupon, looks like we'll have values of x less than negative 2, along with those values between negative 2 and 3, but not including negative 2 or 3. Then we have those values x, which would be greater than 3. Now, in the case of what we have for g of x, okay, I'll just go ahead and write this out in factored form. So for 2x minus 2, okay, this will be 2 times, okay, the quantity of x minus 1. For x squared minus x minus 6, okay, we have with the factors, we have, so we'll have x plus 2 and x minus 3. Notice that there is no cancellation. And again, for the domain, okay, now negative 2 and 3 will be your restricted values. And since both x plus 2 and x minus 3 remain, we're going to have, again, 2 vertical asymptotes. We're going to have that x equal to negative 2 and also x is equal to 3. And just going ahead and looking at what we're going to have for the other asymptote. Okay, so you have in the numerator, we have 2x, or 2 times x to the first, minus 2. So have n equal to 1, and in the denominator, okay, we'll have that m is equal to 2. And for the degree comparison, okay, we have that n is less than m. Okay, so if n is less than or equal to m, okay, there's going to be a horizontal asymptote. But if n is less than m, okay, so there's going to be a horizontal asymptote at y is equal to 0. Okay, so got negative 2 and 3 for x and 0 for y. Okay, so looking at the process of elimination, okay. Okay, so we don't have negative 2. We got 3, but we got the wrong horizontal asymptote. And we don't even have the y is equal to 0 part. Again, we don't even have y is equal to 0 for the asymptote. Don't have it for graph f either. But we do have y equal to 0, x equal to negative 2, x equal to 3. So this is going to come down to either graph D or graph E. And it looks like this will come down to the y-intercept. Now in D, the y value of the y-intercept is just positive, whereas in E, it is barely negative. And you might see the result already, and that's fine. And for the y-intercept, 0y. Okay, so we got, in this one case, you have y is equal to g of 0. And being careful with the sign values. Now 2 times 0 is 0 minus 2 is negative 2. 0 squared minus 0 is 0 minus 6 is going to be negative 6. So we got negative 2 over negative 6. And guess what? We're going to have the negatives to cancel out. And so we're going to have that y is equal to 1/3. So we have with the y-intercept, we're going to have it where when x is 0, y is equal to 1/3. And just going back to what we have here. Okay, so where y just is positive, and that is going to be in graph D, whereas in E, it is barely negative. So after all the filtering through, okay, through the asymptotes and also with the determination of the y-intercept, okay, it turns out that D is going to be that graph that is going to identify what we have for g of x. Okay, so for the graph of g of x, the best one is going to end up as graph D. All right, and just now, last night I had sent out an added test 3 review set, and I tell you what, just kind of taking what we have for, let's say in the case of number 2, I'm going to go ahead and mention this. Just to tie things in together. We have a function. Okay, so you have f of x is equal to 3x squared times the quantity of x plus 5. And then we have times the quantity of 3 minus 2x raised to the third. Okay, and see we have for this item. So you have with f of x, okay, so you have 3x squared times the quantity of x plus 5. We have times the quantity of 3 minus 2x raised to the third. Okay. Okay, so just looking at what we have for, say, the determination of the highest degree term. Okay, and just taking what we have here. Okay, so we have at the lead. Okay, so you have leading coefficient right now is 3. You have times x squared. Now for the end behavior, now this is a bit of a trick problem. Okay, so you have for the first component, okay, so you have 3x squared. Now for x plus 5, think this like x plus 5 to the first. Now we've got your x term, x plus 5. X is going to be the higher order term in the binomial. Now for 3 minus 2x to the third. Now between 3 and negative 2x. Now the higher order term happens to be the one that appears subsequently, which in this case is going to be negative 2x. And that is going to be to the third power. And the highest order term okay, so we have with the components. Okay, so you have 3x squared and we have x to the first. Okay, so that is going to be x. I'll just stress this again. So you have x to the first, and then you have for 3 minus 2x to the third. Okay, so the higher order term For the highest order term, we have negative 2x, and that is going to be cubed. Then we got, again, so you have 3x squared. X to the first is x. Now negative 2x to the third. It's like negative 2x times itself times itself. Now negative 2 to the third is going to be negative 8. And x raised to the third. Okay, so that's going to be x cubed. So guess what? We got 3x squared from the first, x from the next, and then negative 8x cubed from having cubed out minus 2x. So for the highest order term, again, we have 3 times negative 8 is negative 24. X squared times x is going to be x to the third. X to the third times x to the third is going to end up at x to the sixth. Okay, so for what we have in the features, okay, so the highest degree term coefficient, we have a minus 24. Okay, so that's going to be negative. And for the degree n is equal to 6. So that is going to be an even value. Okay. So again, a of n is negative. And we're going to have that n is even. Okay, so you have a negative leading coefficient, n is even. So again, if the degree is even, you're going to have the same vertical behavior at both ends, either both up or both down. And with a of n, the leading coefficient negative, it's going to turn out that the n behavior is that it's going to fall to the left as well as to the right. Okay. And for what we have, okay, so for part A, in behavior, you have falling to the left, falling to the right, or down to the left and down to the right. And in the case of the zeros and their multiplicities, again, this is kind of a trick one here for the zeros and their multiplicities. Again, just kind of stressing the degrees here. Again, x plus 5 is to the first, 3 minus 2x. Again, we have to the third. Okay, so we have with our factors, if I'm looking for the zeros, so I have 3x squared is equal to 0. If I divide by 3, I have x squared equal to 0. And 0 is neither positive nor negative. Okay, so we're going to have from 3x squared, okay, we're going to have that x is equal to 0. Again, we have with x plus 5. If x plus 5 is equal to 0, so we have that x is equal to negative 5. And for what we have in the case of 3 minus 2x equal to 0, so if I move the 3 over, We have negative 2x is equal to negative 3. And in this case, right, so we're going to have that x is equal to 3 halves. All right, so in terms of identifying the zeros and their multiplicities, okay, so you have x equal to 0, x equal to negative 5. You see we have x equal to 3 halves, or you can write that as x equal to 1.5. And for the multiplicities, now 0 stems from this first factor, whereupon we had the variable to be raised to the second power. So 0 is going to be of multiplicity 2. Negative 5 originates from x plus 5, which is to the first. So that multiplicity is going to be a 1. And then we have a 3 halves. This stems from 3 minus 2x, which is raised to the third. So the multiplicity of x is equal to 3 halves, or x is equal to 1.5, is going to be at 3. And now B does not address this, but in terms of crossing or touching the x-axis, again, if the multiplicity is even, then at that 0, the graph is going to touch. So it's going to touch at x equal to 0. And with 1 and 3 as odd multiplicity values, it's going to be at negative 5, or it's going to be at x equals negative 5 and x equals 3 halves that the graph is going to cross. So these are the dynamics so far with the in behavior, fall to the left, fall to the right, and again you have touching at 1, 0 on the x-axis and crossing at a couple. And for what we have in the case of part C, again we're looking at the determination of the y-intercept. And in this one case, you have for the y-intercept, have 0y. Okay, so we have y is equal to f of x when x is at 0. Okay, so it looks like, yeah, so we have 3 times the square of 0 times 0 plus 5 times 3 minus 2 times 0 cubed, and you can just kind of go ahead and stop, okay, because we have 0 squared is 0, 5, and you got 3 to the third, which is going to be 27. Again, I could have stopped a long time ago because here, okay, we have for x squared setting to 0, so it just cascades over the rest of the terms because the product is already going to be at 0. So the y-intercept is going to be located at the origin. So just in terms of taking what we have and sketching. Again, this is going to be a rough sketch. And for a lot of graphs, especially in a program like Desmos, it's like I want a little, sometimes, I want it to be, there to be a little bit more of a curve. Just kind of show where you have like a little bit more horizontal motion than what might be on display. And sometimes the lines might be either too vertical or too horizontal. So just kind of show the dynamic here. So you got on the x-axis, you're going to have 3 distinct zeros. Okay, so you have at -5, also have a 0, and also have at x is equal to 3/2. So you can see it's going to be somewhere about right here, about 1.5. So we'll go ahead and plot these. Okay, so you have -5, 0, and 3/2. And your y-intercept is already going to be the origin. Okay, and notice, okay, we have at the locations. Okay, so you're going to have at the origin. Okay, so the graph is going to touch. At 3/2, the graph is going to cross, and at x equals -5, okay, the graph is going to cross. And just for the general behavior of what we have for the graph of this function. Now, if we look at the end behavior, you're going to have falls to the left. So you have down to the left, falls to the right, down to the right. Okay, so you start with the extreme left and right zeros. Okay, so you have falling, to the left or down to the left. And we have at 3/2, and we have the graph is falling to the right or down to the right. Okay, and just for the dynamics, okay, so if I read the graph in order from left to right, okay, so I have starting beneath the x-axis, okay, and as I get closer to -5, once I get to -5, the graph is going to cross, so it's going to go from below the x-axis to above, and then it's going to start to descend. Okay, but once I get to x is equal to 0, okay, we're going to have the graph to touch, so it's going to kind of like bounce off the x-axis, and then it's going to descend. And once I get to x is equal to 3/2, the graph is going to cross. Okay, so you have moving down and to the right. And so, again, this is not drawing according to scale, but it is the essence of the behavior at the extreme ends, and for what we have in between. Again, this is for f of x is equal to 3x squared times the quantity of x minus 5. And again, we have times the quantity of 3 minus 2x raised to the third. Okay, and we'll throw this in, just touching upon what we have for the quotients and the remainder. And here we got 2x plus 4 as the divisor, and we got 4x to the 4th plus 2x squared plus 6x, okay, as the dividend. Okay, and if I set this up in division terms, okay, so I have 2x plus 4 you're going to have taking into 4x to the 4th. You've got plus 2x squared plus 6x. And I'm going to make an adjustment here. So take this. Okay, so we got with the divisor, have 2x plus 4. And again, we have a linear expression, but again, do not use synthetic division unless if your leading term in the divisor is x, no coefficient in front of it, and no raised power to x. Okay, so if you have x plus 4, by all means, you can go ahead and set things up in terms of synthetic division. Now for the dividend, you want everything from the fourth degree all the way down to a constant to be represented. And if you notice, we have 4x to the fourth, but immediately after that, notice we don't have an x cubed term that is present. So just filling in that void. Okay, we have a 0 placeholder, so you have plus 0x cubed. Then next, okay, we have 2x squared, and then we have plus 6x, and you want to go all the way down to a constant. And notice that there is nothing after 6x. So using 0 as a placeholder again for the missing constant. Okay, so we have things set up where we can perform polynomial division. Okay, so we have with the divisor, and just checking, yes, they have 2x plus 4. Okay, so looking at taking 2x plus 4 into this polynomial. So looking at the leading terms, we have 4x to the fourth divided by 2x, or 2x into 4x to the fourth. So that's going to go 2x cubed times. And if I multiply this binomial by 2x cubed, so first item, okay, we have 4 times x to the fourth, 2x cubed times 4. So this is going to be at 8x cubed. And looking at, again, with line division, we're looking at row by row subtracting. So we have 4x to the fourth to go out. Now we have 0 minus 8x cubed. Okay, so this will be a negative 8x cubed. And 2x squared, 6x, and 0 have not been touched yet. So I'm going to bring these down. Okay, so after bringing or taking 2x into 4x to the fourth, I have for the next round to have 2x into negative 8x cubed. 2 into negative 8 is going to be negative 4. X and x cubed is going to be x squared. So I have distributing negative 4x squared over this binomial. So this is going to be negative 8x cubed. And negative 4x squared times 4, this will be a negative 16x squared. And again, distributing subtraction. Okay, so the cube terms go out. Now we're going to have 2x squared and what's going to be plus 16x squared. So this will be an 18x squared. Now we have plus 6x plus 0. Now we have 2x into 18x squared. So that's going to go 9x times. And distributing. So you have 18x squared, 9x times 4, so this will be 36x. And subtract, so 18x squared will go out. 6x minus 36x, okay, this will become negative 30x. Again, just bring down the 0 from the constant. So we got 2x and we'll go into negative 30x. This will go negative 15 times. And distributing, so we have negative 30x. Negative 15 over 4 is going to be a negative 60. Okay, so we have negative 30x and what's going to be plus 30x. That cancels out. 0 minus negative 60 is going to translate to 0 plus 60. So that is going to be 60. And I cannot take 2x directly into 60. So it's going to turn out that for the quotient, okay, so you have 2x cubed minus 4x squared plus 9x minus 15. Again, we have with the remainder. Okay, so that is going to be at 60. Okay, so just with the quotient and remainder apart, we have this set of results. And just looking at what we have, okay, like if you have like the request to put in the consolidated terms, so you have like 4x to the fourth plus 2x squared plus 6x. You have all over 2x plus 4. If I had to put this in terms of quotient and remainder over divisor terms, so here quotient would be at the front. And so we have for this ratio, so we have 2x cubed minus 4x squared plus 9x minus 15. And then we have plus the remainder 60 all over the divisor, which in this case is going to be 2x plus 4. All right. And, okay, and tell you what, I'm going to let this, okay, be our stopping point. And just an announcement. Okay. And for test 3, okay, I said that I would specify, okay, about when it was going to be available. And in this one case, so for test 3, okay, this is going to be available, okay, Friday, April the 9th at 12 p.m. to Monday, April the 12th at 11:59 p.m. And for the time limit, okay, so that's going to be 100 minutes. Or another way of phrasing that be like just over an hour and a half, or about an hour and 40 minutes. And the exam must be completed in one sitting.